Welcome to the last section of Chapter 3. Congratulations, you've almost made it. We're going to look at some trends or properties of the periodic table. And when I told you before, in the groups they have certain characteristics. Also in the periods, they will have characteristics as well. And so these are just some properties of elements that they will share with elements that are in their groups or their periods. Some of these will make sense to you, others may not. If it's something that you just can't get your mind wrapped around, then just accept it and memorize that that's how it works. Okay, some of these, like I said, you're gonna understand and they're gonna make total sense. Others, it's not gonna make sense, and so don't hurt yourself trying to do that. We're going to look at the representative elements in groups 1A through 8A. Okay, chemical properties are due to how many valence electrons they have. Valence electrons are the electrons in the outermost energy level. Okay, so when we were looking in 3-6, you notice that some of them, in an orbital that could have held 8 only had 6. So if it's in that outer layer, that outer level, and it only has 6, then that's how many valence electrons it has. The group number gives you the number of valence electrons for groups 1A through 8A. So group 1A, you have 1 valence electron, 2A, 2, and then you got to go all the way across to 3A, 3, 4, 5, 6, 7, and finally 8. And when you get to 8, it's full. And so these are the noble gases, and the noble gases are happy, if you will, and so they are full, and so they really don't like to play with the other elements, and so you won't really see them reacting very much. One way we can draw these so that we can sort of see how they're going to bond together is by drawing what's called electron dot or Lewis dot structures, and we're going to do some of this in the labs. But what we do is we look at, in the example here, we're looking at aluminum, and aluminum's electron configuration, which we learned how to do before. It has 2 in the first level, 8 in the second, and then the outermost layer level, I keep wanting to say layer, level has 3 electrons. And so when we write that Lewis dot structure, we just draw the valence electrons. So we put the symbol in the middle, and then we draw 1, 2, 3. Now, the convention for drawing electrons is that you put them at the 4 sides of the elemental symbol. And so 1, 2, and 3. If it's carbon, which has 4, you'd have 1, 2, 3, 4. So it makes sense. You put 1 on each side before you start adding any others. Okay, so then you begin to pair them up. You still will have, like in the case this is no longer carbon. Okay, but if it has 1, 2, 3, 4, 5 electrons in the outer shell, then you would have a pair here. Okay, if it had 6, then you would pair. Does it matter if it's this one, this one, this one? No, it really doesn't. They're in 3 dimensions. Just, ever how you want to do it. Okay? So, as I said, it really doesn't matter which way you draw them. It's, as long as you make sure that you've only got 1 on each side till you get to 4. And then you start adding. So magnesium only has 2, but you could draw it on these sides, this side, top and bottom, side to side, whatever you want to do. Doesn't matter. As long as you just got 1 on each of those 4 sides or less. Okay? And so this is an example of some of these periods where you have group 1A has 1. So everything in that group is going to have an electron, a Lewis dot configuration with just one dot, one electron. 2A will have 2. 3A, remember you got to go all the way across the transitions to get to this one, has 3, like aluminum we just saw. Carbon group 4A has 4. 5A, you have 5. Notice when we get to nitrogen, since it has 5, we do our first pair up. 6A, where you've got oxygen, now you have 2 that are paired. What this is going to mean to us later is that if you have oxygen, for example, you've got 2, 2, 1, and 1. These guys that aren't paired are the ones that are actually going to do something when we start doing chemical reactions. As you move, just one thing to mention is as you move left to right in a period, or if you move, then your valence electrons will increase. But there is no change as you go up and down a group. Anything in that group is going to have the same number of valence electrons. And what do you go by? The number, the A number of the group. Alright, so let's see if we can write the electron dot symbol for each of these elements. Remember, what you're going to do first is you're going to draw it, right? And then you're going to figure out how many valence electrons. How do you know that? By the group number, because we're only looking at representatives. Alright, so let's do carbon together. Carbon has how many valence electrons? 4. So it's 1, 2, 3, 4. Okay, so put us on pause, do those other 2, and then come back and let's see how you did. Alright, how did you do? Chlorine has 7 valence, nitrogen has 5. So you have those 5 dots, and you remembered that you put them singly until you get more than 4, and then you begin to pair them one at a time. Okay? Some of the other properties that we see on the periodic table, atomic size. The atomic size is determined by the radius, that is the distance from the nucleus to that outermost layer, to that valence electrons. Okay, and so this is just like with the circle, that's the radius. All right, and so this increases for these elements we're interested in, the representative elements, from top to bottom of the periodic table. It decreases within the period because you're increasing the number of protons in the nucleus, and what happens is that they begin to pull on those negatively charged electrons a little bit harder. Okay, so as you go down a group, you're going to get larger and larger, farther away from the nucleus. But as you go from left to right, you're going to get smaller because the larger number of protons are going to hold those electrons closer to it. Ionization energy is how much energy it takes to remove one of those outermost electrons from an atom. So when we were talking about we could hit it with some energy and make that electron go up from a low energy level to a higher energy level, and then it would drop back down. Okay, ionization energy is how much energy it takes to do this right here, to take it, ionization energy, okay, to take it from a low to a high. That's ionization energy. This decreases as you go down a group. It increases across the period. Okay, so ionization energy decreases as you go down a group. It increases as you go across. All right. Metallic character. Metallic character basically is how easily it loses electrons. So metallic character, obviously you're going to see more of that in metals. that are on the left side of the periodic table. It's less for nonmetals on the right because they do not give up their electrons very easily because they have so many. So metallic character also increases as you go down a group. It also decreases as you go left to right. And that one makes total sense because you're going towards nonmetals, right? And so here's just a summary of the number of valence electrons, the atomic radius, the ionization energy, and metallic character from top to bottom of a group and from left to right. Stays the same, increases, increases, decreases, decreases, increases, increases, decreases. And so if this is something that you just want to memorize, that's fine. Just so you remember, what that trend is, because that's probably the types of questions you might see. So given the following elements, which one would be the largest? That is, which one has the largest radius? Which one would have the highest ionization energy? And which one belongs to group 5A? So look at that periodic table, look at the trends in the properties, and see if you can figure out. And you're going to be comparing which one's farther down a group, which one's farther to the left or the right to answer these. Okay, so the largest radius is going to be carbon. The highest ionization energy is going to be chlorine. And nitrogen is in group 5A. So hopefully you did real well on that. And that's it. That is the end of chapter 3. We have finished trends and periodic properties, and so hopefully you have mastered this area. Speaking of mastering, you've also got those mastering videos. So make sure that you've done those. Make sure that you go over these again if there's anything that you need. If you need me to work additional problems, just send me what the topic is, and I'll do my best to get some more out there where I'm actually working problems for you. All right.